Hello everyone, welcome to Learnedze. Today in this video we are going to discuss about the inter-VLAN connectivity concept. We already know about the VLANs. VLAN means virtual local area network. In virtual local area network, a physical switch is divided logically, just like this way. Here two VLANs are there, VLAN 10 and VLAN 20. This yellow color PC are in VLAN 20 and this blue color PC are in VLAN 10. Those PC which are in VLAN 10, they cannot be able to communicate or transfer the network traffic from VLAN 10 to VLAN 20. When we forward the traffic between two different VLANs by using a layer 3 device, this thing is called routing between VLAN, or you can say that inter-VLAN routing. But before discussing about inter-VLAN routing, let's just understand why we need a inter-VLAN routing concepts over here. Because here in this scenario, we have intentionally divided this switch into two parts by using VLANs. Now, why we wanted to make the communication between these two separate VLANs, right? Let's say this is your organization network where there are two separate VLANs. One VLAN, that is VLAN 10, is used by, let's say, sales, and VLAN 20 is used by, let's say, marketing guy. So these two VLANs are for two separate departments. Okay, and let's say there is another server over here in your network, and it is connected to the switch by using, let's say, another VLAN that is called VLAN 30. Now the server has different roles. Let's say some roles are for particularly for the sales department, and some roles are for particularly for marketing department. So that means the sales guy will also have to be communicate with the server, and also the marketing guy will also have to be communicate with the server. So in that scenario, the VLAN inter-VLAN connectivity is required. Now let's say this is your office network, and let's say this one is your PC, and you have to manage this network. Let's say there are some errors occurred in this network, so you have to troubleshoot it. So you take your PC and connect to the switch in order to check what is wrong, right? So by default your PC will be in VLAN 1, right? And these PC are in VLAN 10 and these PCs are in VLAN 20. So all the PCs are in different domain. This VLAN 10 in different domain, this VLAN 20 in different domain, and your PC will be different domain. So in this scenario also you will not be able to communicate with all the PC that are in different VLAN. All those PC which are in VLAN 1, only those PC you will be able to communicate, and you will be able to troubleshoot, and you can manage, right? So for you, like, it is not be possible to every time you configure your port directly to the VLANs that you are troubleshooting, right? What if your network is very huge and there are multiple numbers of VLAN available, right? So troubleshooting will not be efficient. So in that scenario, what we can do, we can use this inter-VLAN routing concept in order to manage our network. And let's say as a network administrator, you want to control, you want to manage all of your network remotely. So in that scenario also, this inter-VLAN routing concept will help. Now this inter-VLAN routing can be achieved by using three techniques. Number one is this normal technique that is shown over here. Number two is called router on a stick method, and number 3 is by using layer 3 or multi-layer switches. So here in this session we are going to discuss only about this first and the second technique, and I am going to demonstrate it on the Cisco packet tracer scenario. Now let's go to the packet tracer scenario and try this inter-VLAN routing concept. Let's take this scenario where this is the VLAN 10, these two PC are in VLAN 10 and these two PC are in VLAN 20. So there will be two links for each of the VLANs connecting to the router, that is a layer 3 device, right? So we have to configure this IP address, that is router 1G 0/0/0's IP address 192.168.10.1 as the default gateway of these PCs, that is VLAN 10, and this 192.168.20.1 as the default gateway of these VLAN 20s. So once we have configured those IP address, Then after that, what we are going to do, we are going to go to this router R1 and we are going to assign the IP address, that is 192.168.10.1 at G0/0/0 and 20.1 to G0/0/1. After that, we are going to give the access of VLAN 10 at FA0/5 and VLAN 10, and in FA0/6 we are going to give the access of VLAN 20. Then we are going to try to communicate between the VLANs and we are going to check the connections. After that, since there are two links is used, so this one link is unnecessarily we are using, so that's why we are going to use only one link from the switch, and from that one link defining that link as a trunk and allowing all the VLANs, we are going to configure the router on a stick VLAN concept in this network. So initially no VLANs are there. So if I try to communicate, first it cannot communicate to the VLAN 20 because both are in different subnet. Okay, let's try this by using ping 192.168.20.2. so if I try to communicate from this 192.168.10.2, which is in a different network, and to this 192.168.20.2, which is also in a different network, then they will not be able to communicate to each other. Okay, so now let's go to the router and let's configure their default gateway. Okay, for that let's go to the router, CLI, click no, write down enable configuration terminal, then write down the host name, that is R1, then go to the interface G0/0/0 and add the IP address, that is IP address 192.168.10.1. subnet mask will be 255.255.255.0. then use the no shutdown command. Again, let's go to the interface G0/0/1. Here also write down IP add 192.168.20.1 255.255.255.0 and write down the no shutdown command. And now let's wait till all the links are become green. After that we are going to troubleshoot, like we are going to check the connection between this PC and this PC. Okay, now let's go to this PC and let's try to communicate from this PC to 192.168.20.2. Okay, let's see what will happen. Like till now we haven't configured anything in the switch. So we haven't divided the switch logically, we haven't created VLANs, we haven't assigned the VLANs, right? As you can see, the reply is successful. That means by using this layer 3 device, these two networks can easily communicate. But what will happen when I create the VLANs in the switch and I will assign the different VLANs? Okay, now let's go to the switch and let's go to the configuration terminal and write down the host name of the switch as a SW1, and let's create first VLAN 10, which name will be sales exit, then create VLAN 20 whose name will be marketing exit. So we have successfully created two VLANs. We can check by using do show VLAN command. As you can see, we have successfully created VLAN 10 and VLAN 20. Now we will have to assign FA0/1 and 0/2 to VLAN 10 and FA0/3 and 0/4 to VLAN 20. For that, let's go to the interface range FA0/1 to 2 and here write down the command switch port mode access and switch port access VLAN 10. So we have successfully assigned a VLAN 10 to the port number FA0/1 and 0/2. Now let's go to the FA0/3 to 4 and let's do the same configuration. So as you can see, we have successfully created the VLAN 10 which name is sales and assigned the FA0/1 and 0/2 port to the sales and 0/3 and 0/4 to the marketing. Now this time let's try to communicate from this PC1 to the PC2 which is in VLAN 20. So this time this PC will not be communicating with this PC, right? Because we have created the VLAN in the switch. So we have successfully divided the physical switch in a logical way into two different VLANs. Now what we can do, we can take the help of the layer 3 device. How we can take the help of a layer 3 device? Let's go to the switch 1 and let's configure this FA0/5 as accessing the VLAN 10 so that it can carry the VLAN 10, and the FA0/6 so that it can carry the VLAN 20. For that, let's go to the global configuration mode. Let's go to the interface FA0/5 command and here write down the command switch port access VLAN 10. Then press exit. Then let's go to the interface FA0/6. Here also write down the switch port access VLAN 20 command. Now this will access the VLAN 20. Now let's wait till this state of the link will turn green. Then after that we are going to try to communicate between this PC and this PC again. Now let's go to this PC and let's try to ping from this PC to 192.168.20.2 again. So as you can see, this time although there are VLANs created in the switch, but still they will be able to communicate with each other. So this is the method how we can communicate between the different VLANs. You can check the VLAN status by going to the switch, and let's go to the switch and write down the show VLAN brief command. As you can check that VLANs is assigned into these ports VLAN 10 and VLAN 20, and by the help of the layer 3 router 1 device we will be able to communicate. But here we are using one link extra, two links from the switch to the router, right? So we can configure this inter VLAN routing by using a single link with the layer 3 device. That concept is called the inter VLAN routing. So let's configure that inter VLAN routing concepts, but before that let's remove all the configuration from the router. Let's go to the switch and remove the configuration that we have done in port FA0/5 and 0/6. So let's go to the switch and remove the configuration. So this time I am changing this port so that it will access the VLAN 1 only, not the VLAN 10, because by default this port will be on VLAN 1, right? So you can go to the switch and you can use the show VLAN brief command to check whether all the ports are in the same configuration or not. So as you can see over here, the VLAN sales and marketing are there, but other ports like FA0/5 and 0/6 are in default VLAN, that is VLAN 1. Similarly, if we go to the router 1 also, you can check by using show IP interface brief that right now no IP address has been assigned to the any port. Now let's check whether this PC can communicate with this PC in VLAN 20 or not. So VLAN 10 and 20 will be able to communicate or not, we will check. As you can see, this time the inter VLAN connection is not available. Now we are going to configure the router by using this router on a stick method. Now let's go to the router and now let's create two sub interfaces into these particular interfaces. That means let's go to the global configuration mode and let's go to the interface G0/0/0. So this is one of the interfaces, and we can create sub interfaces prior to this. So for that we have to write down the dot 10. So we are creating another sub interfaces over here in this interface G0/0/0. As you can see, the interface gigabit ethernet G0/0/0 dot 10 has changed to up. Now we can add the IP address in this sub interface. As you can see, it is written over here, it is sub interface, right? So here we can write down IP add, then we can add the IP address, that is 192.168.10.1, which is VLAN 10's default gateway. Okay, 255.255.255.0, but we cannot directly add the IP address over here. As you can see, when I press the enter button, as you can see, we cannot directly create the IP address, assign the IP address in a sub interfaces. Okay, it will only be allowed if that interfaces is configured as a part of IEEE 802.1q or the ISL VLAN. Now first of all, I have to change encapsulation method of this sub interface command to a dot one q method. Then I can add the IP address. For that we have to write down the encapsulation dot one q, and we have to write down the VLAN, for which VLAN. So we have to write down the VLAN ID, which VLAN we are creating this interface, sub interface. Okay, so this sub interface we are going to use for VLAN 10. So I am going to write the VLAN 10. So this command we have to write down. Then after that we can add the IP address. IP add 192.168.10.1 255.255.255.0. So in this sub interface we have added this IP address. Now let's write down the exit command and let's try to create another sub interface for the VLAN 20. Let's do the same configuration. Now we can check whether our sub interfaces are correct or not by using show IP interface brief command. As you can see, in the sub interface .10 we have assigned the 192.168.10.1, which is a VLAN 10's default gateway. Similarly in .20 we have assigned the 20.1, which is a VLAN 20's default gateway. Now I already discussed that suppose you are a network administrator and you want to troubleshoot this network, right? So in that scenario you will just simply plug in your device to the switch in order to troubleshoot, right? So this will be on by default VLAN. Okay, so let's say your PC has IP address of 192.168.30.2. okay, and it has a default gateway of 192.168.30.1. okay, so now let's make this IP address configure in this interface G0/0/0. For that let's go to the router 1, let's go to the global configuration mode. Here let's go to the interface G0/0/0. So this time in the G0/0/0 interface we are configuring the IP address 192.168.30.1. subnet mask will be 255.255.255.0, and we have to write down the no shutdown command, but it's already in the up state. Okay, so all the configuration has been done in this router R1. Now let's try to communicate from this PC to that PC. Okay, that is the connection between inter VLAN, different VLANs we are going to check. Okay, for that let's go to the 192.168.10.2 PC and let's try to ping to 192.168.20.2 PC. As you can see, all the packets are lost. Why? Because we forgot to configure this interface FA0/5 as a trunk. So we have to configure this FA0/5 interface of the switch as a trunk, and only then this trunk can carry the VLAN information to the router, and only then the communication can be happen. So let's go to the switch, let's go to the interface FA0/5 5. That is for that, for we have to go to the global configuration mode, config T, then we have to go to the interface FA0/5, and we have to write down the command switchport mode trunk. So now this link will become trunk, and we can check that which port in which VLAN. For that we have to use the show VLAN brief command. As you can see, FA0/1 and 2 is in VLAN 10. We can see over here. FA0/3 and 4 is in VLAN 20. 3 and 4 is in VLAN 20. Then rest of the port in VLAN 1. That means if this laptop is your troubleshooting PC, then this laptop is in VLAN 1. So earlier, when we don't use router on a stick or the inter VLAN connecting method, at that time from VLAN 1 you will not be able to communicate to VLAN 10 or VLAN 20 or any other VLAN. But now we are in configuring these devices as a router on a stick, or we are configuring the inter VLAN connectivity. So now let's check what will happen when we try to communicate from VLAN 1 to the other VLANs, and also from VLAN 10 to the VLAN 20 and the other VLANs. So let's go to this PC again and let's try to communicate to the VLAN 20 device, that is 192.168.20.2. Now let's see what will happen this time. First packet will be lost, second packet will also be lost. Let's see what will happen in the third packet. So as you can see, we are getting the reply from the third packet. So now by using this router on a stick method, it can easily communicate, right? Now let's say this one is your PC and you are being a network administrator, you want to troubleshoot each and every VLAN. So you want to communicate with each and every VLAN. So your PC by default, when you connect it will be on VLAN 1, right? So we have configured the IP address, that is 192.168.30.2 in this PC. Okay, so from this PC, now let's see what will happen if we try to communicate to one PC from the, VLAN 10 and another PC from VLAN 20. Okay, so I'll write down the ping 192.168.10.2. okay, so as you can see, this PC can easily communicate with the VLAN 10 PCs. So similarly we can try by going to the VLAN 20 PC. Okay, let's try to ping 192.168.20.3 PC from the VLAN 20. Let's see how it will respond. So as you can see, if this is your PC, you can troubleshoot any PC from the switch. So by using a layer 3 device, we can communicate between two VLANs or different VLANs in a switch, but we need to have a layer 3 device. But although we can use another method, by using a layer 3 switch, we can communicate between different VLANs. So that time we'll have to use the layer 3 switches. So we are going to discuss about that concept in the later videos. I hope you have understood the configuration of the normal inter-VLAN routing concepts and the router on a stick method. Here this is the scenario that we have discussed earlier in the packet tracer scenario, and these are the configuration commands for the switch and the router R1. You can pause the video and you can write down this command. Thank you for attending this session, and in order to join our complete CCNA training course, you can contact us at info@learnedze.com. Thank you.